So, what are the effects of aging and how battery ages? These are some of the questions that we will be solving in this next section. Over time, all batteries degrade due to different factors. And understanding all of the aging mechanisms in the battery cells is going to be essential for optimizing the battery performance and also to be able to extend its lifespan. So let's start answering the question of why do batteries age? Battery aging is going to be a natural process in every battery cell, and it's going to be influenced by different factors like the chemical reactions, the mechanical stress, as well as the thermal conditions. Each of the elements will contribute to gradual loss of the capacity and the performance, and there are several causes that will reinforce that loss of capacity. So first, one of the main causes is overcharging or over-discharging our battery cell. When the battery is repeatedly charged beyond its recommended voltage, or when we discharge it too deeply, it can lead to permanent changes in the chemistry of the battery cell, and this eventually will result in the loss of capacity and in a lower efficiency. Another common reason is the mechanical stress. This can also play a major role in the battery degradation, since vibrations, for instance, shock, and the expansion and construction of the battery cell that naturally occurs when we are charging or discharging the battery. All of those mechanical causes can cause physical damage in the internal components of the battery, and this can cause damage, for instance, in the electrodes and in the separator, and over time even lead to short circuits and to become a risk in the safety of the battery. Another major factor for aging is gonna be the aging cycling. So each time that the battery goes beyond a charge and a discharge cycle, a small amount of the battery will wear out, and the wears will occur naturally. The more the cycles that the battery undergoes, the more degradation it accumulates, and eventually it will reduce little by little the total capacity. Even when a battery isn't in use, it will also experience another type of degradation, that is the calendar aging. This type of degradation will happen due to the slow and ongoing chemical reactions that are happening within the battery over time, and this happens even if the battery is sitting on a shelf and it is not being used. And finally, one of the also most relevant ones is the thermal aging. In the thermal aging, basically, this is basically one of the biggest contributors to the battery degradation, and excessive heat accelerates all the chemical reactions inside of the battery, and excessive heat then will cause also faster degradation and increase the internal resistance of the cell. Also, not only the excessive heat, but the very low temperatures will impact the battery performance and will contribute to the degradation. Here we have one diagram that is showing all the different causes that we already discussed. What is the mechanism for the degradation, what are the laws, and what is the final effect that we will collect them into the capacity fate and the power fate that it will be explained here. So now we want to solve the question of what happens as the battery ages. There are two main effects that collects all the effects of aging, and these two main effects is gonna be the capacity fate and the power fate. The capacity fate means that over time the battery can hold less energy, and this will result in shorter operating times in our application, as well as lower energy that is going to be available. Several of the factors that we already discussed will produce the capacity fate, but mostly it's going to be that we have less lithium inventory because of the different degradations that we are having, and also we will have it caused by the breakdown of electrode materials, for instance. On the other hand, there is the power fade, and the power fade will refer to the battery declining the capability of delivering power when it is needed. So as the battery ages, the internal resistance of the battery will increase, and this means that it can provide the same level of power as before, and this leads also that it will require a slower charging, and it will reduce the overall performance, especially under high load conditions. Some of the causes of this is going to be the loss of the active anode materials as well as the loss of the active cathode material. So aging will affect differently the different parts of our battery, and it will have different effects of it. At the negative electrode or in the anode of our battery, experiencing aging will mean and will cause mostly the formation and the continuous growth of a solid electrolyte interface, that is this layer over here. This layer forms naturally as a protective barrier between the electrolyte and the anode materials, and at some point over time it gets thicker and thicker, and it starts consuming the active lithium, and this will reduce the battery overall capacity. High temperatures and operating at high state of charge levels will accelerate the growth of this layer, increasing also the internal resistance of the battery and leading to the power fade. Additionally, when we are having repeated cycling in our battery, and due to the expansion and the construction of the cells and of the anode material, and because of that expansion and construction and the mechanical stress, it will also result in cracks in our negative electrodes and in the loss of electrical contact with the electrode structure that will increase as well the impedance of the cells and lead on the capacity fade and in the power fade of the battery. Now let's see what happens in the positive electrode. So in the positive electrode or in the cathode, here we will experience aging mostly due to structural changes and the chemical reactions that are occurring during charge and during discharge. Over time, high charge rates and extreme operating conditions like temperatures, high or low temperatures, all of those will lead to phase transitions. And these phase transitions within the cathode materials will cause cracks and loss of active materials that at the end will result in a reduction in the ability of the cathode to effectively store and release lithium ions, leading to the gradual loss of the battery capacity. Additionally to this, the electrolyte decomposition at high temperatures and high state of charge will produce unwanted gases and further degradation of the performance of the battery. And another cause of aging at the positive electrode will be the corrosion of, and this is the corrosion of the current collectors that can also occur during time, resulting to the poor electrical connection, and also it will result in having power fade and reduced power output for our battery. So this is a summary of the main effects of aging. In the next section, we will also review how this causes imbalances in our battery packs and how we can react to prevent issues because of that.